In this video, we are going to discuss the halogenation and sulfonation. These are again the two types of electrophilic aromatic substitution reactions, and these reactions are shown by the phenols. Okay, so what happens in the halogenation? Halogenation is actually the addition of a halogen, particularly chlorine and bromine, to the aromatic ring of the phenol. So when phenol reacts with bromine water or chlorine water, we get a polyhalogen derivatives. Okay, so here is the reaction. The phenol reacts with bromine. Okay, the we get the poly substituted. We have the poly substituted phenol, and in addition to this, we also get the hydro bromine. Okay, so we are getting the product. This is 1 2 3 4 5 6, so it is 2 comma 4 comma 6 tribromo phenol. Similar reaction can be shown if we react the phenol with the chlorine. Okay, so if we need a mono substituted product, then what we need to do is we need to add the bromine in presence of the we need to add the bromine to phenol in presence of a non-polar solvent. Actually, what happens, the phenol is converted when we add phenol to the water. It's converted into the phenoxide ion. Okay, it's converted to the phenoxide ion in presence of water. We get the phenoxide ion. Okay, and phenoxide ion, the negative charge on this phenoxide ion is very activating. It will activate the ring towards the addition. As a result, all the three CH bonds, all these three CH bonds at two ortho positions and one para position, these bonds will be broken because because of the activating effect of this negative charge of the phenoxide ion. As a result, all the positions, that's both of the ortho positions and the para positions, will be substituted by the bromine. But if we add bromine to the non-polar solvent, then it prevents the activating effect of this negative charge of the carbon, of the oxygen. As a result, if we are adding the non-polar solvent, okay, carbon disulfide or carbon tetrachloride, then we only get a specific product in this reaction. Okay, mono product in the reaction. As in this case, we are getting the two products. One is the para phenol, and one is the orthobromophenol. Okay, so this will be the para product will be obtained as the major product in the reaction, and this will be the minor product of the reaction. So this will be the minor product and this is the major product, because here the heavier groups, these are the two heavy groups, these are farther away from each other. That is why there will be no steric hindrance, as in case of this, the bromine and the hydroxyl ion here have a steric hindrance to each other. Therefore this product will be a minor product of the reaction, and this para product will be the major product of the reaction. Okay, next we'll be discussing the sulfonation, and sulfonation is the reaction of phenol with the sulfuric acid. When we add phenol to the concentrated sulfuric acid, we get a para and ortho sulfonic acid. So we get two products. One is the phenol sulfonic acid, and one is the orthophenol sulfonic acid as the product. If we perform this reaction at low temperature, then the ortho product is the major product of the reaction, and if we perform this reaction at high temperature, then the para product will be the major product. Okay, and also if we can convert the ortho isomer to the para isomer by simply heating at 373 degrees Celsius. Here is the reaction. We have the phenol, we have the reagents, we have sulfuric acid in presence of low temperature. We have low temperature, and this reaction gives us the ortho isomer. Okay, this is orthophenol sulfonic acid. And if we are performing this reaction at higher temperature, 373 Kelvin, which corresponds to 100 degrees Celsius, then we get the para isomer as the major product. Okay, this is the para isomer, paraphenolic sulfon, paraphenol sulfonic acid. Okay, And also we can convert the isomer to the para isomer by just heating it at the 373 Kelvin Celsius temperature. Okay, so this is these are the simple two reactions for which we should remember these important points. We don't need the detailed mechanism of this reaction.